Quantum numbers. The set of numbers used to describe the position and energy of an electron in an atom are called quantum numbers. There are 4 quantum numbers, namely principal, azimuthal, magnetic, and spin quantum numbers. Principal quantum number. The principal quantum number indicates the size and energy of main shell and is denoted by n, where n is equal to 1, 2, 3, 4, so on. Let us take 4 elements: hydrogen, nitrogen, magnesium and calcium, with 4 atomic numbers 1, 7, 12 and 20 respectively. We can observe that hydrogen has one shell with one electron represented by K shell. Nitrogen has 2 shells with 2 electrons in first shell and 5 electrons in second shell, representing K and L respectively. Similarly, magnesium has 3 shells, that is K, L and M. Whereas calcium has 4 shells, K, L, M and N. In this way, with the increase in N value, that is, when moving outward from the nucleus, the size and the energy of the main shell increases. Angular momentum quantum number. The angular momentum quantum number indicates the shape of each subshell and is represented by L, where L is equal to 0, 1, 2, 3 till n minus 1. In any main shell, L represents the number of subshells and are designated as S, P, D and F. If value of L is 0, it is represented by S subshell and its shape is spherical. Similarly, for P, it is 1 and shape is dumbbell. For D, L is 2 and the shape is double dumbbell. And for F, L is 3 and the shape is 4-fold dumbbell. Magnetic quantum number ML. Magnetic quantum number describes the orientation of orbital with respect to other orbitals in the region of space in an atom. It is denoted by ML. For any given value of L, ML is equal to 2L plus 1 and ranges from minus L to plus L. Thus, total number of ml values for a given L value is equal to 2L plus 1, which denotes the total number of orbitals. Let us take nitrogen atom, for which atomic number is 7. These 7 electrons are distributed over 2 shells. If n is equal to 1, there is only one way in which a sphere can be oriented in space. The only allowed combination of quantum numbers for which n is equal to 1 is when n is equal to 1, L is 0, M is 0 and the electronic configuration is 1s. There are 4 orbitals in n is equal to 2 shell. When n is equal to 2, L is 0, M is 0 and the electronic configuration is 2s. When n is 2, L is 1, M is minus 1 and the electronic configuration is 2p. When n is 2, L is 1, M is 0, the electronic configuration is 2p. When n is 2, L is 1, M is also 1, the electronic configuration is 2p. There is only one orbital in the 2s subshell, but there are 3 orbitals in the 2p subshell. One of these orbitals is oriented along x-axis, another along y-axis and the third along z-axis of a coordinate system. These orbitals are known as 2px, 2py and 2pz orbitals. Spin quantum number ms. Spin quantum number describes intrinsic angular momentum of an electron. The two possible orientations of electron spin are clockwise spin and anticlockwise spin, which are represented using the quantum number as +1 by 2 and -1 by 2. Consider helium atom whose atomic number is 2, that is, it has 2 electrons. Here we can see that one electron is rotating clockwise whereas the other electron is rotating anti-clockwise, representing the spins are anti-parallel.